How AI is revolutionizing earthquake detection in Yellowstone. Prepare to be amazed by a breakthrough in earthquake science. Artificial intelligence is revolutionizing how we handle the challenge of measuring small, yet significant, tremors at Yellowstone. In this week's installment of Yellowstone Caldera Chronicles, a column authored by scientists and collaborators from the Yellowstone Volcano Observatory, graduate student Alicia Armstrong from the University of Utah's Department of Geology and Geophysics explains how AI is offering fresh solutions to age-old seismic problems. Yellowstone National Park is no stranger to seismic activity, with frequent minor earthquakes occurring in rapid succession. While these small quakes might barely register on our sensors, they happen far more often than their larger counterparts and hold key insights into regional earthquake hazards and underlying geological processes. However, traditional methods struggle to accurately calculate the magnitudes of these small events, especially when they overlap during seismic swarms. But here's where it gets controversial. Could leveraging AI be the answer to a problem that has long eluded standard techniques? Under typical conditions, earthquake magnitude is determined based on the energy released during the event, as captured by a network of seismometers managed by the University of Utah Seismograph Stations, UUSS. Each seismometer independently records the energy, and these individual measures are then averaged to arrive at the final magnitude. Yet, with small earthquakes, there may not be enough clear measurements, or multiple events might occur nearly simultaneously, leading to overlapping signals that can confound analysts. This is why approximately 2% of earthquakes in the UUSS data are reported with a placeholder value of -9.99, a sign of measurement challenges. And this is the part most people miss. Artificial intelligence, particularly deep learning models similar to the ones behind ChatGPT, is now at the forefront of addressing these issues. These advanced models take in raw ground motion data from seismometers and learn to identify patterns, much like a student reviews a series of test questions with an answer key. Once the model is trained, it can assess new seismic data and estimate earthquake magnitudes even when events are closely spaced. In addition to deep learning, there is a more straightforward yet potent form of machine learning that relies on human-defined data features rather than raw data. In a recent study, UUSS scientists employed this technique by training models to calculate earthquake magnitudes from brief windows of seismic data. By developing individual models for each station in the Yellowstone region using the historical earthquake catalog, these models account for specifics like the amplitude of the seismic signal and event location. This method effectively expands the data pool, leveraging multiple types of seismic waves from more stations and ultimately yielding up to 4 times as many measurements as traditional methods. It's important to note that this AI approach is designed to complement existing techniques rather than to replace them. Conventional methods continue to perform admirably in most cases, except when dealing with closely spaced, small earthquake events where errors tend to mount. Furthermore, machine learning models have limitations. They excel only when applied to earthquakes that are similar to those in the training dataset. For example, a model trained on data from the Yellowstone region might lack the nuance to correctly estimate the magnitude of an event near Hebgen Lake if it has seen few similar cases before. If the training data predominantly features earthquakes above a certain magnitude, predictions for events below that threshold could be less reliable. By combining predictions from multiple station-specific models, scientists can identify and weed out inaccurate estimates, though uncertainty remains a challenge. Future improvements will likely include generating not only a magnitude value, but also an accompanying confidence level, which would better inform us about the reliability of each measurement. What do you think about using AI to tackle long-standing problems in seismology? Could this controversial approach redefine how we monitor earthquakes, or does it risk overlooking rare but critical events? Share your thoughts in the comments. This is a debate that could change the way we understand our planet's seismic behavior. Unveiling Yellowstone's hidden earthquakes. 86,000 quakes discovered by AI. Imagine a world where we could uncover hidden dangers beneath our feet, places that have been quietly shifting and rumbling for years, unknown to us. That's exactly what a team of international researchers has achieved with Yellowstone National Park, one of the most geologically active regions on Earth. Using artificial intelligence, AI, they've revealed an astonishing 86,276 earthquakes beneath Yellowstone's surface, a number that's 10 times greater than what was previously known. But here's where it gets controversial. The majority of these earthquakes were part of swarms, groups of small, interconnected quakes that spread and shift within a small area over a short time. This finding challenges our understanding of how earthquakes work, especially in such a volatile environment as Yellowstone. But how does this discovery impact our safety and energy needs? Yellowstone is more than just a beautiful park with geysers and hot springs. It sits atop one of the planet's most active volcanic systems, a fiery foundation that has the potential to drastically reshape our world. The study, published in Science Advances, was led by Western University engineering professor Bing Li, who used machine learning to analyze 15 years of seismic data from the Yellowstone caldera. This innovative approach allowed the team to identify and assign magnitudes to a staggering number of previously undetected earthquakes. The Yellowstone caldera, spanning parts of Wyoming, Idaho, and Montana, is a massive geological depression formed after a volcanic eruption drained the underground magma chamber, causing the surface to collapse. This new analysis significantly enhances our understanding of the region's seismic and volcanic behavior, offering a much more detailed and comprehensive dataset. One key finding is that more than half of the earthquakes recorded in Yellowstone were part of earthquake swarms, unlike aftershocks, which are smaller earthquakes following a larger main shock. These swarms occurred along relatively immature, rough fault structures, which the researchers believe were caused by a mix of slowly moving underground water and sudden bursts of fluid. This discovery challenges our understanding of how earthquakes form and interact. But what does this mean for global safety and energy? Li, an expert in fluid-induced earthquakes and rock mechanics, hopes that these insights can be applied elsewhere to improve safety measures and inform the public about potential risks. Moreover, understanding seismic patterns could guide geothermal energy development away from danger zones. Prior to machine learning, detecting earthquakes was a time-consuming and cost-intensive process, often missing many events. Now, with the ability to analyze vast amounts of historical waveform data, we can learn more about seismic regions around the world. This discovery not only gives us a clearer view of Yellowstone's interior, but also opens up new possibilities for understanding and predicting earthquakes globally. As Li says, we can apply statistical methods that help us quantify and find new swarms that we haven't seen before, study them, and see what we can learn from them. So, are we ready to embrace this new era of seismic discovery? And what other hidden dangers might be lurking beneath our feet? Let us know your thoughts in the comments below. Is Yellowstone's supervolcano about to erupt? Debunking the myths. Imagine the panic. Rumors are flying that Yellowstone National Park's supervolcano is about to blow, and wildlife is supposedly fleeing in droves. But here's the truth: these claims are nothing more than misleading viral videos and false alarms. Let's dive into the facts and separate fiction from reality. Yellowstone National Park is home to one of the world's most powerful volcanic systems, known as the Yellowstone caldera. This supervolcano, spanning roughly 55 by 72 kilometers, was formed during a colossal eruption around 640,000 years ago. Its deep magma reservoir fuels the park's famous geysers, hot springs, and bubbling mud pots. While the idea of a supervolcano might sound terrifying, scientists have been keeping a close eye on it for decades, ensuring there's no immediate threat. Despite the dramatic headlines, there's no evidence that Yellowstone's volcano is about to erupt. The U.S. Geological Survey, USGS, and the Yellowstone Volcano Observatory confirm that the volcano's alert level remains at normal code green. Recent data shows low seismic activity, with only minor earthquakes recorded, and no significant earthquake swarms. The park's geysers, including the famous steamboat geyser, are behaving normally, with no unusual pressure or heat detected. But here's where it gets controversial. Viral videos circulating on social media claim to show mass migrations of wildlife, such as bison, elk, and even grizzly bears, supposedly fleeing the park. These videos have sparked fear and speculation, but experts say they are either AI-generated or misleading. Wildlife photographer Tom Murphy, with 5 decades of experience at Yellowstone, points out that grizzly bears don't travel in groups unless there's a major food source, which doesn't exist in the park. Wildlife biologist Bill Hamilton adds that while migration patterns do occur, they happen mostly during winter, not summer. Predators like wolves and mountain lions follow their prey, but even then, the numbers are limited. You're not going to see mountain lions migrating in herds, Hamilton explains. That video is nonsense. Recent research has mapped out large magma pockets beneath Yellowstone, but scientists stress there's no cause for immediate concern. Only one pocket, located in the northeast part of the park, is currently molten, and even that has a low melt percentage, far from what's needed for an eruption. The study also revealed that the magma pockets are not all connected, making a super-eruption unlikely in the near future. So, what would happen if Yellowstone did erupt? The last major eruption, around 630,000 years ago, ejected over 1,000 cubic kilometers of volcanic debris. A future supereruption would have catastrophic consequences, including ash-covering cities like Chicago and San Francisco, widespread destruction within a 100-kilometer radius, and global temperature drops by as much as 4 degrees Celsius to 10 degrees Celsius. However, scientists emphasize that the next eruption is likely centuries or even millennia away. In April 2025, geologists discovered a new hydrothermal feature at Norris Geyser Basin, a 13-foot wide hole filled with milky blue water. While this might sound alarming, experts say it formed through small, natural geothermal changes, not a sign of an impending eruption. The spread of misinformation about Yellowstone's wildlife and volcanic activity might seem harmless, but it can mislead the public about real geological threats. Wildlife experts and volcanologists warn that understanding the natural rhythms of Yellowstone is crucial. People start believing what they see in these videos, and that undermines public understanding of how nature really works, Hamilton says. Despite the viral hype, Yellowstone National Park remains stable. Animals like bison and elk do move around during different seasons, especially winter, but there's no mass exodus happening now. The volcano system is under constant surveillance, and scientists agree, there's no eruption on the horizon. Stay informed by following updates from reliable sources like the USGS, Yellowstone National Park Service, and the Yellowstone Volcano Observatory. Always question viral videos before accepting them as fact, especially when it comes to something as important as nature's most powerful forces. And this is the part most people miss: the role of social media in amplifying false narratives. How can we, as a society, better discern fact from fiction in the age of AI-generated content? Share your thoughts in the comments. Do you think platforms like TikTok and Instagram should do more to combat misinformation? Or is it up to individuals to fact-check what they see? Let's discuss.